Welcome to Day 12 of Wisdom Academy AI, my incredible wizards. I'm Anastasia, your super thrilled AI guide, and I'm absolutely buzzing with excitement today. Have you ever wondered how AI can predict numbers, like house prices or student grades, with magical precision? We're about to master the basics of linear regression, a foundational ML technique, and it's going to be an unforgettable journey. You won't want to miss a second of this, so let's get started. I've brought my best friend to say hello. Linear regression is our star today, and I'm so excited to share its magic. It's a supervised machine learning algorithm used to predict numerical values, like continuous outputs, in a simple yet powerful way. For example, it can predict house prices based on their size, helping us estimate costs accurately. It works by fitting a straight line to the data points, finding the best relationship between variables. This makes it the simplest way to predict with AI. I love how elegant it is. Let's uncover how linear regression works, and I'm so excited to break it down. It finds the best fit line for your data points, creating a straight path that captures the trend. The equation is y chaten mx plus b, where m is the slope and b is the intercept, defining the line's position. It minimizes the error between predicted values and actual data points, ensuring the best fit possible. This is done using a method called least squares, which optimizes the line perfectly. It's like drawing a line through magic. I'm so thrilled to see it in action. Linear regression has key assumptions we need to understand, and I'm so thrilled to share them. First, there must be a linear relationship between x and y, meaning the data follows a straight line trend. The data points should be independent, so one point doesn't affect another, ensuring unbiased results. Errors should be normally distributed with constant variance, meaning they're consistent across predictions. In multiple regression, we avoid multicollinearity, where predictors aren't too correlated. These assumptions ensure our magic works perfectly. I love how they guide us. Let's compare simple and multiple linear regression, and I'm so thrilled to explain the difference. Simple linear regression uses one predictor, x, to predict y, like using house size to predict price. Multiple linear regression uses many predictors, like x1, x2, and more, to predict y, such as size and location together. For example, predicting house price with just size is simple, but adding location makes it multiple, capturing more factors. Multiple regression adds complexity, but often improves accuracy for better predictions. Both are powerful tools for AI magic. I love their versatility. Evaluating linear regression models is so important, and I'm so eager to share how we do it. We use metrics like mean squared error, or MSE, to measure the average squared difference between predictions and actual values. R-squared tells us how well the line fits the data, with values closer to 1 meaning a better fit. For multiple regression, we use adjusted R-squared to account for extra predictors, ensuring fairness. A lower MSE and higher R-squared indicate a better model, showing our predictions are on track. These metrics help us perfect our magic spell. I love seeing the results. Linear regression has challenges, but I'm so determined to tackle them. It assumes a linear relationship, so it may fail if the data is nonlinear, requiring a different model. It's sensitive to outliers, which can skew the line and lead to poor predictions if not addressed. In multiple regression, multicollinearity, where predictors are too correlated, can cause issues with interpretation. There's also a risk of overfitting if we use too many predictors, making the model too complex. We'll overcome these with magical solutions. I'm so excited to solve these puzzles. Let's overcome linear regression challenges, and I'm so thrilled to share these fixes. First, check for linearity using scatter plots to ensure the data fits a straight line before proceeding. Remove outliers or transform the data, like using logarithms, to reduce their impact on the model. Address multicollinearity by using feature selection to pick only the most relevant predictors, avoiding overlap. Use regularization techniques, like ridge regression, to prevent overfitting by keeping the model simpler. These are magical fixes for a better model. I'm so excited to apply them. Linear regression has amazing real-world applications, and I'm so inspired to share them. In business, it can predict sales based on marketing spend, helping companies optimize their budgets. In healthcare, it predicts patient recovery time, aiding doctors in planning treatments effectively. In finance, it's used to predict stock prices or assess risk, guiding investment decisions. In science, it analyzes experimental data trends, revealing insights from research. Linear regression is a versatile spell for many fields. I'm so thrilled by its impact. Here are some tips for using linear regression, and I'm so thrilled to share my wizard wisdom. Start with simple regression if you're a beginner, as it's easier to understand and apply right away. Always check the assumptions, like linearity, before building your model to ensure it works correctly. Use visualizations, like scatter plots, to understand data trends and confirm the relationship is linear. Experiment with multiple predictors if your data needs it, adding more factors for better predictions. Keep practicing to perfect your magic. I know you'll become a linear regression wizard.